For centuries, science worshipped a clockwork dream. If you knew every particle's position and momentum proclaimed Laplace's demon, you could predict the cosmos from the flutter of a moth to the drift of galaxies past, present, and future, etched in perfect script. Then came Werner Heisenberg, holding a lantern to the tiniest shadows. He found that nature does not allow both gifts at once. Pin down a particle's location more precisely than the width of an atom, and its momentum blurs like ink in water. Sharpen the momentum, and the particle's whereabouts dissolve into probability mist. It isn't technological clumsiness, it is the universe's handwriting. A limit woven not by measurement tools, but by existence itself. Strip away every vibration, cool an atom to a whisper above absolute zero. And still the product of its uncertainties refuses to shrink beyond that boundary. Determinism cracks not from chaos, but from a deeper order that trades perfection in one realm for ambiguity in another. The cosmos will divulge secrets, but never all of them at once. To glimpse the reason, picture a single violin note stretched into silence. The purer the pitch, the longer it rings. Shorten the burst, and overtones bloom. Mathematicians call this Fourier's law. Confining a wave in one domain spreads it in another. Every particle is a wave packet, a pulse of possibilities. Squeeze its position, tighten the spatial envelope, and the momentum spectrum widens, a shimmering fan of wavelengths. Let the wave wander broad and gentle, and its momentum sharpens like a spear. No tinkering circumvents the trade-off, because the particle is the wave, localization is distortion. Fire electrons through a nanoslit just billionths of a meter wide, and their diffraction pattern splays across the screen, proving their momentum uncertainty has ballooned. Do the same with fullerene molecules heavier than 7,000 hydrogen atoms, and the pattern returns grand but obedient. Even buckyballs cannot dodge the wave rule. Photons, neutrons, atoms, viruses, however massive, they carry a quantum heartbeat that insists precision be paid for in complementary coin. Uncertainty is not a veil over hidden facts. It is the rhythm by which waves exist in space and time. The inevitable soundtrack of a universe that refuses absolute stillness or pinpoint certainty. Cool a pendulum, and it slows. Cool it further, and it stills. Classical intuition says perfect calm awaits at absolute zero. Quantum logic refuses. Even when thermal jitters are bled away, every atom, photon, and field retains a faint, restless tremor, zero-point energy. Picture an electron bound to an atomic nucleus. If position and momentum could both fall to zero, the uncertainty product would break Heisenberg's limit. Instead, the electron hovers in a whisper-wide orbital, a standing wave that never fully settles. The residual motion keeps atoms from collapsing and gives matter its size. Zero-point energy escapes the microscopic too. Chill liquid helium to a fraction of a degree above absolute zero, and it refuses to freeze. The atom's quantum jiggle overrides the lattice that would lock them into ice. Bring two uncharged metal plates a hair's breadth apart in vacuum. And vacuum fluctuations push them together, the Casimir effect. Measurable proof that empty space seethes with invisible modes. Far above your head, the same vacuum seeds cosmic microwave background ripples. In your laptop, it sets the noise floor for every transistor. Motion that never stops may sound like celestial nuisance, but it is the crackle that keeps stars aflame, chemistry alive, and the fabric of space humming with potential. Position and momentum share one trade-off. Energy and time share another. Borrow a tiny packet of energy, and the universe allows the loan so long as it's returned rapidly. Borrow more, and the repayment deadline shrinks. These fleeting overdrafts manifest as virtual particles, ripples that flicker into being, then fade before detectors can flag them as real. Between two electrons, virtual photons zip back and forth, mediating electric repulsion. Inside a bar magnet, a storm of virtual quanta binds domains into north and south. No conservation laws are broken. The energy ledger balances when T expires. At the edge of a black hole horizon, quantum loans become cosmic withdrawals. A virtual particle pair pops from vacuum. Gravity yanks one partner past the event horizon, while its twin escapes as Hawking radiation. The black hole pays the debt with its own mass, evaporating atom by atom over eons. Even radioactive decay clocks the universe by this principle. The shorter-lived and excited nucleus, the broader its energy spread, imprinting uncertainty onto every gamma ray it emits. Our finest lasers, atomic clocks, and PET scanners all ride this line with. Energy time uncertainty is not a loophole. It is the gears of interaction, the fleeting handshake that lets forces work. Black holes glow and random decay inject genuine unpredictability into the cosmic script. Imagine shrinking an electron's orbit until it almost kisses the nucleus. Electrostatic attraction says closer, closer, promising lower potential energy with every step. But Heisenberg stands guard. Tighten the electron's position too much and its momentum uncertainty. Its quantum pressure soars, adding kinetic energy that counters the Coulomb pull. Equilibrium emerges where these two forces balance, carving out the Bohr radius and every atomic shell beyond. This tension between attraction and quantum pushback builds the scaffolding of chemistry. Hydrogen's solitary electron spreads just enough to create gentle, covalent bonds. Heavier atoms, flush with electrons and Pauli exclusion, arrange layered orbitals that set the periodic table's rhythm. Strip uncertainty from nature and electrons spiral inward. Atoms collapse into pinprick nuclei. Matter as we know it ceases. Your desk, your bones, the air. Everything solid owes solidity to the restless blur, encoded in Heisenberg uncertainty principle. Even white dwarf stars rely on this principle. Squeeze stellar ash under gravity, and degenerate electrons push back, suspending a sun's mass on a sphere no larger than Earth. Quantum fuzziness is not decorative. It is structural steel, holding up atoms, planets, and the quiet weight of night. 14 billion years ago, the universe was a subatomic ember, fields vibrating with quantum uncertainty. During cosmic inflation, that ember ballooned faster than light's own pursuit, stretching microscopic fluctuations into macroscopic ripples, minuscule overdensities that would later attract dark matter, gas, and eventually galaxies. Today, we see their fossil imprint in the cosmic microwave background, a modeled tapestry of one part in 100,000 temperature bumps. Each bump a quantum hiccup amplified across intergalactic emptiness. Point a radio telescope at the sky, and you're reading the static of Heisenberg's jitter writ, 100,000 light-years wide. Zoom further. Gravitational wave detectors strain to hear primordial hums, stochastic ripples perhaps birthed by the same quantum seeds. The large-scale cosmic web, with its filaments and voids, is a three-dimensional echo of vacuum noise frozen on scales larger than clusters of galaxies. Thus, uncertainty is not confined to atoms. It sculpts the scaffolding of the cosmos. Every spiral galaxy, every star nursery, even the supercluster that hosts our Milky Way, owes its existence to random quantum flickers stretched to celestial grandeur. The night sky is a mural painted by probability, its brushstrokes chosen in the first trillionth of a second after time began. Physicists are stubborn. They turn limits into laboratories, shrink a beam of single photons until its waist is narrower than a bacterium, and watch the diffraction halo bloom. Direct proof that the uncertainty in position and the uncertainty in momentum refuse divorce. Trap a single calcium ion in an electromagnetic cage, cool it with laser light, and measure its position spread. Never zero. Always the ground state wiggle set by zero-point motion. Energy-time trade-offs leave fingerprints too. Excite sodium atoms with a nanosecond laser pulse, and their spectral lines broaden precisely, as Heisenberg uncertainty principle predicts. An atomic heartbeat engraved in color. Particle physicists push further. Unstable pions born in accelerators live trillionths of a second, and their rest mass smear follows the same rule, confirming that nature tallies every loan with quantum bookkeeping. Squeezelight labs flip the script. They narrow photon number uncertainty at the cost of phase fuzz, beating the shot noise limit in gravitational wave detectors. LIGO's record-breaking sensitivity to space-time ripples depends on this engineered give-and-take, turning Heisenberg from barrier into amplifier. Each experiment, photon halo, atomic line width, quantum squeeze-all whisper the same refrain. Uncertainty isn't an error bar we hope to erase. It is a constant carved into the grain of reality, And with clever tools, we can bend, but never break. It's arithmetic. Scan your fingertip with an MRI, and you exploit proton spins dancing to quantum tune. Their resonance width fixed by the uncertainty principle for energy and time. Probe a single atom with a scanning tunneling microscope. Electrons tunnel, because position is fuzzy and energy momentarily borrowed. Inside GPS satellites, atomic clocks count microwave ticks of cesium. Clock's ultimate accuracy is shackled by energy-time uncertainty, yet honed by decades of squeezing noise toward that limit. Miss a few nanoseconds and your phone maps you to the wrong street. Cryptographers harvest radioactive decay or photon arrival jitter to generate randomness no algorithm can predict. Quantum key distribution uses the impossibility of simultaneously knowing polarization and phase to catch eavesdroppers. Steal info. Stored in uncertainty, get caught. Emerging quantum sensors read changes in magnetic or gravitational fields, so slight they would vanish beneath classical noise. But balanced atop Heisenberg's edge, they detect submarine wakes, underground voids, perhaps even dark matter waves. All rely on trading precision in one variable for ignorance in another, dancing with the limit rather than fighting it. Without uncertainty, we lose lasers, semiconductors, PET scans, and the encryption that shields every online handshake. The fuzz is not a flaw. It is the fertile ground where innovation takes root. Uncertainty tells us that nature refuses perfect focus, yet it does not show the full spectacle of possibility. To see that, we must let systems hold many truths at once, interfering like overlapping melodies before the final note sounds. In Part 3, Superposition. Reality in draft mode. We will watch quantum states layer like transparent pages, discover why Schrödinger's cat was always more parable than paradox, and learn how chlorophyll quantum computers and tunneling enzymes wield superposition as everyday toolkit, where uncertainty sets the blur. Superposition paints the multicolored draft. Together they reveal that the quantum is not a quirky footnote to classical chapters. It is the manuscript still wet with ink, beneath every story the universe will ever tell.